First of all, we are going to discuss about this particular video, that the name of this video is going to be Timeline at Scale. Okay, this article is written by Rafi Krikorian. Okay, he was a CTO of Twitter, I guess, in 2012. Okay, it doesn't matter if he was not a CTO. So, but yeah, he was an amazing engineer, and like I just checked his LinkedIn, and he's doing some amazing work in tech. Okay, so he wrote this article, Timeline at Scale, for Twitter in 2012, and so we are going to discuss about it. So let's talk about the problem first of all. So the problem is that how Twitter handles the timeline. Basically, whenever we open the Twitter and you are going to see a lot of posts, basically the first top 10 posts, then next 10 posts, then next 10 posts, how your timeline is going to be coming on your mobile app. This, we are going to talk about this engineering here. Okay. So the problem is, let's say for example, there is a person Alice right now. I'll just take a laser pointer. There's a person Alice who has 4 friends, Bob, Charlie, David, and Emma. Okay, and they have posted something. Okay, Bob has posted at 9, good morning. Charlie is having coffee. Emma working on AI, and David is watching football at 9:05. Okay, so now Alice follow all 4 of them. Now what is going to happen in that case? Whenever Alice is going to open the Twitter app, or let's say Instagram, now what is going to happen? Alice is going to see his feed. In the case of Instagram, in the case of Twitter, you can say timeline. So at 9:05, whenever Alice is going to open the app, so the first thing that Alice will say, the David's post or David's tweet, then Emma's, then Charlie and Bob. So the basic idea is these are in the descending order. First 9:05, then 9:03, 9:02, and 9. Okay, so this is the simple logic. This is how our Instagram is showing, Twitter is showing, that the latest post will come first. Simple. Okay, now we are going to talk about the scale. Okay, so this post is written in 2012. So basically at the time the scale was something 150 million plus active users, 300k timeline queries per second. Basically 300,000 people were opening the timeline, basically the first page of the Twitter or Instagram. Let's say 400 million tweets per day. So many people are tweeting or posting feeds on Insta. 30 billion timeline deliveries per day. So this was a scale that we were talking about. And let's see. First of all, let's take a simple scenario that we have 10k users. Okay, how we can make the system. Okay, we have to solve this problem, and that is going to be pretty easy when there are going to be 10k users. Okay, so let's say there is a Alice. Okay, and we have the 2 tables right now. Simply 2 tables in MySQL. So what we are going to do, first of all, we find out the Alice friend. Okay, so let's say we have the Alice ID in users table, and somehow we just get this Alice ID. We are going to search in the friends table, and we'll find it out who are the Alice's friends. So we'll figure it out. We have 1, 6, 7, and 9. Okay, basically Bob, David, Emma, and Charlie. These are their friends ID we get. And now when we are going to figure out the friends, okay, so this query, we have just completed this query, and now we have the friends. What we are going to do next, we are going to pass this list of friends in the tweet table. Okay, what are the tweets that Alice friends have posted? Then we passed there. We are going to order by timestamp so that we can get this thing 9:05, 9:03, 9:02, and 9:0. And when we get this thing as well, now what we can do is to do the pagination. Basically first 10 posts, then next 10 posts, then next 10 posts. Okay, we get all the posts, and now we can implement the pagination. Okay, that is going to be the final step. Basically we find all the posts or tweets, and after that we implementing the order by timestamp or order by ID. Limit 10, basically the first 10 posts, and offset is the page number. Basically on the first page 10 posts. If you want to see on the second page, then offset to 10 posts. Okay, this is the simple logic, and this logic is going to work pretty well when there are going to be only 10k users, I guess, or let's say 50k users. This logic can work. Okay, there is no problem in this logic. Simple logic working perfect. Simple engineering, I guess. Okay, now let's talk about the problems. First of all, our use case is going to be that we want now let's talk about the use cases. Okay, think of it that I follow 3,000 people. Okay, I am following 3,000 people. Secondly, I am a celebrity. Okay, 20,000 people are following me. But I'm not a celebrity. But let's assume that I'm a celebrity. So what is going to happen in that case? The 20,000 people are following me. So whenever I am going to post something, 20,000 people, whenever they are going to open the app, they are going to see my post. Okay, for example, Messi posts something. Let's say lakhs of people are following him. So let's say 70 lakh people following. So 70 lakh people, whenever they are going to open the phone, okay, then they are going to see the Messi's post. This is something that we want to do. So this thing can be slow. Secondly, think of it that many people are scrolling. Okay, just keep on scrolling. Lot of APIs we are getting. Okay, lot of scrolling, lot of refreshing is going on. They just want to keep on seeing the latest post. Okay, so this is the problem. And the idea is that, for example, the idea is that we want a result in less than 100 milliseconds. Okay, we just discussed about one simple logic here, that this simple logic is amazing. Okay, it can work, but the only problem is that it is going to give the result. Definitely it will give the result, but the only problem is that it is going to give the result in less than 10 seconds or less than 15 seconds or in 5 seconds. But we want a result in 100 milliseconds. We want to improve our speed. At the scale, this logic will not work. This was the whole problem. Okay, now let's come to this guy, Rafi Krikorian. He wrote an amazing blog. He solved this problem. Okay, so this is the blog. You can go and check this blog. From this blog, I got an idea to make this video. And similarly, I'm going to make more videos like this. Okay, now let's talk about the solutions. Okay, that is also discussed in this blog. You can go and read it. Now, the first thing is that we want to know the first thing that we should know is about the Fanout on read. The Fanout on read says what we are going to do whenever we are going to get something into the database. Okay, we are just going to put it into the database, and whenever the user wants to see it, we'll just search into the database and give the response. Simple logic. We are going to put it to the database, and whenever the user is asking something, we are going to return it from the database. That's what we have discussed. Our simple logic is also known as Fanout on read logic. Simple. Let Alice, first of all, we search into the friends table. After that, we have the simple select query, and then we have this pagination logic. Problem that we have studied till now in Fanout on read or in our simple logic, that both are the same thing, that it will not work when we have the multiple, let's say we have 30,000 followings. Okay, so what is going to happen whenever a user come and he follow, let's say 30,000 people, then in that case we are going to run a query and this list size is going to be 30,000, and whenever we pass it into this query, there's going to be a log, 30,000 rows are going to be blocked or something, and after that we are going to return back a response. That is going to take a lot of time. We have to improve the speed. Okay, so Fanout on read is failing here. Okay, that our simple logic is failing, that we have discussed. Now let's talk about the solution. The solution is going to be our Fanout on write. Okay, that is the second solution that we are discussing. That is not the final solution, but that is the improvement that we can do. Okay, what we are going to do is that there is going to be a user. So what I'll do is I'll just remove the messy logic right now here from here, and let me just make it better for you. So there is going to be a user who is going to post or let's say tweet something. So I'll just take the laser pointer. So the user is going to tweet. It is going to be stored into the database. Now what we are going to do? We are going to return back to the user. Okay, so basically user is posting something, it is going to the database and it is saved. User is happy that their post has been tweeted or posted. Now what is going to happen? When this is going to be into the database, we are going to make a webhook from the database. So basically the simple logic can be, whenever we are going to get an entry into a particular tweet table, or in the case of Instagram into the post table, what we are going to do in that case, we are going to send a webhook to a queue. Let's say it is a Kafka or SQS, anything. Okay, so we put it into the queue, and after that this queue will send this data to the Fanout service. The Fanout service is consuming from the queue right now. Okay, I'll remove this. This is unnecessary, this number. Okay, now what is going to happen? Fanout service is consuming the data, and after when the Fanout service is consuming the data, I improve the logic in the Fanout service. Instead of a MySQL, let's keep the friends in the graph database right now. Okay, this is not the point of discussion why we are using the graph database. Of course, you can put this thing into the MySQL. Then of course you have to go with this query, select star from friends where LSID equals to. Okay, we got the tweet here in the Fanout service because this tweet is consumed by the Fanout service. We find the user ID who tweeted it. We find the friends. So GraphDB is going to work perfectly, give you the friends. Okay, so this is why I use the GraphDB to get the friends basically. So when we get this friends, now what is going to happen after that? We are going to send this data to the Redis simply. And in the Redis, the idea is going to be that there is going to be a key, and in front of key, there is going to be a list of tweet ID. Key and list of the tweet ID. So the simple, basically Alice. Okay, let's say if Alice has posted something in the Bob, because Bob is Alice's friend. So what we are going to do, there is going to be a Bob, and in front of Bob, what we are going to do, we are going to just store the tweet ID. And the logic is going to be, this tweet ID is going to be a list of tweets, and there's going to be a max capacity of these tweets. Let's say the max capacity is going to be 1000. So till 1000, we are going to just keep on appending into these into this list, and after that, whenever there is going to be, let's say, 1001 tweet, we are going to use the FIFO. First come, first serve. The new tweets are going to come and the last tweets are going to go out from that particular queue. Okay, so this is the idea. We are going to just maintain a key and list of tweets in our Redis. Okay, and we're just storing the tweet IDs, not the actual tweets. Okay, so this is how the fan out on write is working. Okay, so this Redis, or you can say a cache that we are using. Now a user will come and user will ask for a tweet. Okay, the user will say that, please give me my timeline. So the request will go to the tweet service, and now what is going to happen? Just tweet service will simply go to this Redis and simply say, just give me the first 10 tweets. So let's say David is coming and David is asking for the first 10 tweets. It will go to this particular key, return these tweet IDs, 10 tweet IDs. It will go to the database and give us the final result. Simple. Okay, so this is how the fan out on write is working. We, instead of getting the data from the directly to running all these queries, we are just going to get the tweet IDs from the Redis, then search it from the database and return back the tweet to the tweet service, and we are returning it to the user. Now there is a small problem in this whole approach. Okay, this approach is working perfectly when there are normal users. Let's say users like me, I'm not a celebrity, then it is working perfectly. But think of this, there is a small flaw in this whole flow, that for example, instead of a normal user, let's say Ronaldo posted something. So what I'll do is I'll just write it down here. Let's say Ronaldo is posting something, or let's say Messi posts something, Taylor Swift, or let's say Sachin Tendulkar, and let's say if you are not still getting Modi ji posted something. Okay, if these guys post something, what is going to happen? The request will go to the post service, it will reach to the database, it will go back, okay, and these guys will know that they have posted something. Perfect. Now, how the companies are going to handle this situation? When these guys are posting something, they cannot do this fan out on write approach. There is a small problem in that. Whenever these guys are posting, they are going to have, let's say, millions of followers. Okay, so for example, if let's say there is going to be, let's say, that number of followers, so that much records will go to the queue, that much records are going to be consumed by the Fanout service. These two things are fine, I guess. But think of it, that much records are also going to be update in the Redis. That is the big thing. Okay, so let's say there are going to be 2 lakh records that we have to update in Redis. Okay, for one user, let's say Modi ji posted something, then the 2 lakh records are going to be updated. 20 lakh records are going to be updated actually. Okay, so this is the problem that we cannot do in this fan out on write. So what can be a simple approach? What we can do is, in our database, let's change the logic. Okay, so I'm not going to discuss this logic here right now. Let's talk about the final solution first. Okay, so we understand the problem. For the celebrities, we cannot do it. This is the whole thing, because for the celebrities, there are going to be a lot of followers. So let's say we can make a custom logic. Whenever a user is having less than 20k followers, we can go with fan out on write. Whenever a user has plus 20k followers, then we can go with the fan out on read. Okay, so this is the particular logic. This logic can also change according to the person to person, according to the region as well. There can be multiple logic, but let's keep it simple. Let's say if a user has a less than 20k, then it is a normal people. If a person has more than 20k, then we can just say he's a celebrity. Simple. Now let's talk about the final solution. Final solution, we are going to do a push and pull approach, basically fan out on read plus fan out on write. This is what Rafi Erickson has proposed, and this was the final solution. This was a thing that is used in Twitter right now as well. It was written in 2012, but it is still used. Okay, so we have the logic that 20k is our threshold. Okay, so first of all, we are going to talk about when I am going to post something. Okay, what is going to happen in that scenario? Simple. What is going to happen? I posted something. It will go to the database. Then it will go to the queue, webhook. Okay, and now we have a fan out service. This fan out service will figure out who are my friends. Okay, let's say I have 5 friends, or let's say 20,000 friends. Then these 20,000 people's Redis key is going to be updated. Basically, their list is going to be updated. Simple. Because I am not a celebrity right now, we can update 20,000 records in Redis, or we can just say 2,000 records in Redis. We can update that, but fine. But now let's say we have someone else. Let's say we have Messi is posting something. Instead of a normal user, now Messi is posting something. In that case, what is going to happen? What we can do is that it was going to be a simple post. Okay. Now what is going to happen? That he is going to post something. It will go to the database. Now the check is going to be, let's say, is celebrity equals to true. Instead of is celebrity equals to false, it is going to be is celebrity equals to true. Reason being, because Messi is going to have more than 20k followers. This is our simple logic. In that case, what we can do is either we can leave it here. Okay. that we are not going to run this whole thing. Fanout on service, this logic, there is no need of this logic. Okay, we are just simply keep this thing into our database. Simple. Okay, now let's discuss about how users are going to see their timeline. A simple user is coming like me. What is going to happen in that case? I'll open the Twitter. I'll see who are my friends. Okay, who are my friends? So basically, I'll figure out my friends with the help of this graph database. Simple. When I get my friends, what is going to happen in that case? I'll just go to this Redis. Okay, I'll get their tweets. I'll merge them and I'll return to the user. Let's say if I also follow 20 celebrities. Now I have some friends plus 20 celebrities. Okay, now there is a combination. Think of it. Okay, so what is going to happen? Normal records I can get it from Redis. Perfectly fine. But for the celebrities, what is going to happen? I have 20 celebrities only. And you remember that there is a celebrity check also. So I can just simply figure out that these are the celebrities. For these 20 celebrities, what I can do is tweets. Basic tweets I'm getting from Redis, from my friends. But if that person is a celebrity, then what we can say, let's say I am following 20 celebrities. And after 20 celebrities, let's say these 2 celebrities have posted also something. That these 2 posts, I can just get it from the database also. Because celebrity data is not that much. Think of it. Celebrities are going to be very less. Normal people are going to be so much. This is the whole thing. Because we have just 20 celebrities, let's say 100 celebrities. And only out of 100 celebrities, only 10 celebrities has posted something. Okay, so 20 celebrities are there. And out of them, let's say 2 celebrities has posted. So what we get at the... so what is the final result? Friends tweets that we are getting from Redis plus 2 tweets that we are getting from the celebrity. So at the end, we can just figure out that there are going to be the 10 tweets. Some are coming from the Redis and some are directly coming from the databases because these are the celebrity tweets. Okay, how we can improve this approach as well? There is a small tweak that we can do. Whenever there is a celebrity equals to true, okay, instead of a database, if you want to make the system more fast, what we can do is when the celebrity equals to true, we can make a separate cache for the celebrity. Okay, this is a separate cache where what we are going to do, we are going to make a tweet in front of the celebrity's ID. So now we know that this is the celebrity ID. These are the 2 celebrities I'm following. Let's say I'm following Messi and Taylor Swift. So I'll get their tweets and I will see which are the top 10 tweets according to the timestamp. We can simply, like a simple logic in tweet service, we can just sort the data and we can figure out the top 10 tweets and we can return. Okay. So that's how we can put one extra cache, extra Redis here. Okay, so the idea is going to be pretty simple. We are going to manage this celebrity with the help of Fanout on read approach. Basically directly from the database with a simple logic. But whenever there are going to be normal users, okay, who are going to have very less friends, okay, then in that case, we are going to use a Fanout on write approach to increase the speed, improve the speed. Okay, so this is the whole logic. This whole blog is available here on the slideshare.net.com. You can go and read there. I'll put this blog link into the description as well. Timeline at Scale by Rafi Krikorian. So this is all for the video. Thank you for watching me and we will meet in our next video where we are going to decode something else of Twitter. So thank you and bye bye.